Hello and welcome back to this channel. Dear students, this topic is MIMO, that is multiple input, multiple output cellular communication. Uh, we will start the topic today's session with this design example of OFDM. In the last video, I have already covered OFDM, that is orthogonal frequency division multiplexing. If you haven't yet watched the last video, do watch the video. So we'll start with design example of OFDM. WiMAX is a good example where orthogonal frequency division multiplexing OFDM is used. WiMAX is basically wireless interoperability for microwave access. Now, in case of this system, WiMAX system, the total number of subscribers, that is N, are 256, and the bandwidth per subscriber used is 15.625 kilohertz. These are the standard values. It is the bandwidth per subscriber. So we can easily write B by N, that is bandwidth per subscriber, is equals to 15.625, and it is in kilohertz. Therefore, B is equals to N into 15.625. Value of N is 256. N is the total number of subscribers. So it is 256 into 15.625. Do remember, this value is in kilohertz. This is basically kilohertz. So into 10 raised to 3. So if you solve this, you will get this value of B, that is equals to 4 into 10 raised to 6. That means it is 4 megahertz. So this is the bandwidth which is used for WiMAX system. Now there is one term which is called coherent bandwidth. Coherent bandwidth, and value of coherent bandwidth is 250 kilohertz. This bandwidth, which is the bandwidth per subscriber, is 15.625 kilohertz, which is very less than this value, that is coherent bandwidth, which is denoted by BC. So this value 15.625 is very less than BC, that is coherent bandwidth. That means every subscriber can get experience of a flat fading. We know that fading is the effect where different signals are traveling through different branches and they are getting attenuated. So since the bandwidth is less compared to the coherent bandwidth, you will get a flat fading. There would be a much more effect of the flatting. Now let us discuss the symbol time without CP. What is CP? We have last time discussed the concept of CP. CP is basically cyclic prefix. Some kind of, you may remember it like this, some kind of coding is used. So that is the cyclic prefix. It is the prefix code, means before the data this code word is added as shown here. So this is the CP, which I have written some values. We'll discuss how we got these values. This is the CP, that means this part is added before the data. This is the actual data. So let us discuss the symbol time, that means how much time will require to transmit the symbol if we are not using CP. That means it is without CP, without a cyclic prefix. As I said, cyclic prefix is some kind of coding used for transmitting the data. So it is without CP, which is given as N by B. Now we have both the values of N and B. So N is number of subscribers, that is 256, and value of B, we have just now calculated the value of B, that is 4 megahertz. So it is 4 into 10 raised to 6 hertz. Now if you calculate this value, it is equals to 4 microseconds. Sorry, this is 64 microseconds. So this value comes to be 64 microseconds. This is the value of symbol time without CP. Now if cyclic prefix is used, that means if you are using some kind of coding in this case, then it is 12.5% of the symbol time without CP. So if you are using cyclic prefix, then we can write duration, that means time duration with CP with cyclic prefix is equals to 12.5% of 64 microseconds. So we can write this value as 12.5 divided by 100 into 64 into 10 raised to minus 6, because this is in microseconds. So if you calculate this value on the calculator, then this answer will be 8 microseconds. That means if you are using the cyclic prefix, then duration required is 8 microseconds. Now next part is number of samples in CP. So we'll calculate number of samples in cyclic prefix. This number of samples are given as this time period, that is 8 microseconds. I am calculating number of samples which is used in cyclic prefix, that is 8 microseconds, which is the duration divided by sample time. Basically it is this much duration for CP divided by sample time. So it is 8 microseconds divided by sample time is 1 by B, and we have got the value of B, so I will write this value over here. So it is 8 microseconds, that means 8 into 10 raised to minus 6, this value of 8 microseconds. This B is the bandwidth which we have this value 4 megahertz. So this is 1 by B, so it becomes 4 into 10 raised to 6. So this value comes to be 32. So there are 32 samples in the cyclic coding. Now we know that total there are 256 subscribers, so we can write total number of samples. Now see what we did. If you use the cyclic prefix, we have calculated the time period required with cyclic prefix, which is 8 microseconds. Number of samples in cyclic prefix is 32. So total number of samples, we know there are 256 subscribers, plus these 32 samples are required for cyclic prefix coding. So it will be total 288. So 288 number of samples are required. Now I have drawn the frame structure. This cyclic prefix has 32 samples. Its duration is 8 microseconds. We have calculated this value. This is 256 OFDM samples. That means we can say 256 OFDM subscribers. The duration of CP is 8 microseconds. This duration is 64 microseconds, that is symbol time without CP. We haven't considered CP in this part. CP we did the calculation for cyclic prefix separately. So this time duration is 64 microseconds. So naturally total time duration will be 64 plus 8, that will be 72 microseconds. And total number of samples, just now we calculated, this CP contains 32 samples, that is we calculated it using this formula. So that comes to be 32 samples. So I have written CP 32 samples, and there are 256 OFDM samples. So total number of samples are 288. So this is WiMAX is a good design example of OFDM. The question can be like this: define OFDM and explain it with some practical example. So this explanation you can write. Actually, these are the calculations. You need to mention all these calculations and without you should not forget to mention this term, that is a flat fading. This is you are getting because this bandwidth required in WiMAX is less than the coherent bandwidth, which is 250 kilohertz. The next part is, first I will tell you what the question can be asked. What is MIMO cellular communication and how MIMO works? So this is the block diagram of MIMO system. As I mentioned earlier, MIMO stands for multiple input, multiple output. So it is usually used in case of cellular communication. This is the simplified diagram of MIMO system. That means, make it in more simple. multiple transmitting antennas are used and multiple receiving antennas are used. So this is the diagram of transmitter which contains n number of transmitting antennas. These are transmitting antennas. Whereas this is the block for receiving side, and there are n number of receiving antennas used. So I have shown different array paths. For example, if I am talking about this antenna, then the signal can transmit like this. It is directly applied to the second antenna. This is the second number antenna at the transmitter side. The signal directly gets traveled to second number of antenna at the receiver side, or this signal may get traveled to the first antenna of receiver, or it may get traveled to the nth antenna of receiver, and so on. Basically, why to use such system? See, in case of urban areas, the major issue is that when the signals are traveling, there are so many obstacles, like tall buildings are there, like moving automobiles are there, and the signal gets obstructed. So there are multiple divergence for the signal, and because of which lot of disturbances are obtained. So to avoid this kind of system is used. This MIMO system basically makes use of the intelligent network, so that at the receiver, whatever different signals are obtained, they are compared, and accordingly the strongest signal is selected. So that is the advantage of MIMO system. Now I have highlighted few points that your answer should include all these points. First is STTD, that is space time. STTD, space time transmit diversity. So it is space time transmit diversity. What does this mean? The same data is transmitted and coded. Basically, whatever data you want to transmit, you need to apply the coding. So same data is transmitted and coded through different antennas. There are n number of antennas which I have shown. The system can be like this: 2 into 2 system. That means 2 input antennas and 2 output antennas are used, or it is 4 into 4 system. 4 input antennas and 4 output antennas are used. Likewise, it can be n into n system. So what we have written, the same data is transmitted and coded through different antennas. So power of the transmission gets increased. P stands for power, and signal to noise ratio, that is SNR, also gets increased. The second point which I have written is spatial multiplexing. We know that multiplexing means many signals can transmit at a time. So it is spatial multiplexing, that means many signals are transmitted parallelly through the free space. So it is spatial multiplexing. So it delivers parallel data to the receiver by using multipath. Many different paths are used, and the receiver receives the signals from the corresponding antenna. So it improves the capacity of the system, as well as it increases the output of a system. And third point is uplink collaborative MIMO link. Two devices can collaboratively transmit the data of same subchannel on same subchannel, which increases the uplink capacity. That means at simultaneously the different number of devices can send the data using the same channel, so it increases the channel capacity, which we call it as a uplink capacity. Uplink is basically transmitting, the word which is used in transmitting side, and downlink is at the receiving side. So this is the way how the MIMO system works. Next part is MIMO system model. That means how to write the mathematical model for multiple input, multiple output system. Suppose there are T number of transmitting antennas. So small t represents number of transmitting antennas. R, small r represents number of receiving antennas. Since there are T number of transmitting antennas, I will write this vector, this matrix, as matrix S is equals to x1, x2 up to xt, where xt is the last transmitting antenna. Similarly, there are, let us say, r receiving antennas at the receiver side, which is denoted by y. So this is again a column matrix which is expressed as y1, y2 up to yr. Now, since this is a multiple input, multiple output system, there can be a cross connection. That means jth number of transmitting antenna can transmit the signal to ith number of receiver, which will cause the fading effect. We have already discussed this concept of fading. You can say it is a cross connection from jth transmitting antenna to ith receiving antenna. Since there are t transmitting antennas and r receiving antennas, total fading coefficients will be t into r or r into t. So I have expressed the matrix for fading coefficient like this. So this is the matrix which is denoted by capital H. This is the matrix for fading coefficient. It is H11, H12 up to H1t, then H21, H22 up to H2t. Likewise, the last term is, this is HR1, HR2 up to HRT. So this is the matrix for the fading coefficient. Now output matrix is given as y is equals to H x plus n, where this n is the noise matrix. That means whenever the signals are reaching at the receiver, some kind of noise is getting added. So this again we need to introduce into the system. So it is represented as a column matrix like n1, n2 up to nr, which represents a noise matrix. So it's very simple. Just you need to remember this formula, y is equals to hx plus n. So if you want to write the things in terms of final equation, then we can write it like this. So this is the matrix H. I will write it like this. So this matrix Y, that is y1, y2 up to yr. This is matrix Y, which is equals to, I am talking about this term, which is equals to this matrix H we have already written into matrix X, that is written as x1, x2 up to xt, plus noise matrix. Noise matrix is this matrix, that is n1, n2 and so on up to nr. So this particular case, this is the case which is called the model system model representation of MIMO system. Next part is MIMO OFDM. This is the block diagram of transmitter side. If the question is explain the concept of MIMO OFDM, or what's the combination of MIMO and OFDM, you need to explain both transmitter and receiver. As I said, this is only the transmitter block. So in case of transmitter, first we are using S/P, that is serial to parallel demux for transmitting antenna. This is the entire demux serial to parallel conversion for the transmitting antenna. Now we are, let us say we are using n number of transmitting antennas. This is known as a transmitting antenna array, where we are using different number of transmitting antenna. So after this serial to parallel converter, for each antenna, this is the path for antenna number 1, this is the path for antenna number 2 and so on. For each antenna, again serial to parallel conversion and demux, that is demultiplexing is done. So this indicates different parallel paths. Then after that, the signal is calculated as inverse fast Fourier transformation. This is called endpoint inverse fast Fourier transformation, endpoint IFFT. Then we need to add the CP. In this case, CP is cyclic prefix coding. So you, if you want, you can well add one block after this, or even you can just mention this thing in the answer. So if you want to add cyclic prefix, then you will have to again convert P/S, that is parallel to serial conversion, and then it is applied to the CP, that is cyclic prefix is added, and then the signal is given to the transmitting antenna. So same is happening with every block. Basically, what's the concept of this? It is MIMO, multiple input, multiple output, as well as OFDM. So it gives you the double profit, a double advantage of multiple antennas, as well as the orthogonal frequency division multiplexing technology. Next part is, this is MIMO OFDM receiver section. It consists of n number of receiving antennas, which are shown over here. So these are n number of receiving antennas. First part at the receiver side is, you need to remove the cyclic prefix coding, that is CP removal block. Then we are converting, this is a serial data. After removing the CP cyclic prefix, you will be getting the serial data. So we are using serial to parallel conversion, that is oblique P and demultiplexing. So output of this block will give you a parallel data. Then we are performing n-point inverse fast Fourier transformation. Now this diagram, this connection is important for MIMO detection. See, we are using multiple antenna system, so we have to combine the signals from all the antennas. So make the thing simple. The first connection of each antenna, like if I'm talking about first MIMO detection, this detection, then this is the first line, first connection. Let us say this is the connection from first antenna. This is the connection of second antenna. Again, this connection is connected over here. Similarly, the from third side, that is this connection. This I will make it with, highlight it with the red pen. So this is again the same connection. Likewise, so every first connection of each endpoint IFT block, that is at corresponding to each receiving antenna, are combined. Similarly, for this thing, for this block, this is the second block, so every second connection is combined. Likewise, this is the nth block, every nth connection is combined. After that, parallel to serial conversion is used, that is and multiplexing is performed, and last is combination of all multiplexing operations, then the final data is obtained. So this is the explanation for MIMO OFDM receiver. But do remember, for MIMO OFDM system you need to explain both transmitter and receiver side. Next, you need to also include advantages and disadvantages of the system. Advantages are bandwidth increases, then data rate is high, that means data rate is increased, spatial efficiency is also increased, then reliability of a link is increased. This upward arrow, it indicates there is increase in the values. There are few disadvantages, quite obvious disadvantages. It needs multiple antennas, then there is a high power consumption. Obviously we are using so many antennas and corresponding blocks, and there is a high implementation cost. So these are few advantages and disadvantages of MIMO OFDM system. So dear students, that's it for unit number 2 of the subject cellular network. Actually the syllabus is limited as far as this CN cellular network subject is concerned. So that's it for today's session. Thank you and all the best for your exam.